All right, so we're now going to start multivariable functions, which is coming in after simplex and dual. Now, it may seem kind of weird that we're doing this now, but it all is going to lead to the concept of optimization. Just like simplex and dual was all about minimization and maximization, that's what we're leading to. So please bear with me. We're going to go on a little a little jaunt into left field, and then we're going to come back to something that will, I think, make a lot of sense. Okay, so starting with just multivariable functions. You've been dealing with these for years and years and years. It just didn't, you get the notation. We didn't get the notation that we're now going to have. So, for example, when I asked you to find the volume of the box, or any teacher asked you to find the volume of a three-dimensional object in the past, you said, no big deal, I can do that, right? The volume equals length times width times height. Well, now we're actually just going to go to three-dimensional notation, which says the same thing, except notice our function notation off to the side. What we're saying here is just my volume is a function of length, width, and height. So you're just telling the reader the variables that are in this function are all listed listed here. So if a reader, for example, was out in the field collecting data, they wouldn't have to search through your entire equation to find all their variables. They would just look right here and say, oh, I know what I need. So similar here, for a business application, this is profit, revenue, and cost, right? Where profit is a function of revenue and cost, where it is calculated by revenue minus cost. Right? So anyway, there's not really much going on here. It's just a new notation. So for example, if I gave you this, if I gave you P of revenue, let's see, let's do 1,050. Okay, what would that mean? Well, we're going to interpret that the same way we've always interpreted function notation is everywhere I have an R, I'm going to replace that with 1,000, and everywhere I have a C, I'm going to replace that with 50. So therefore, my function now is 1,000 minus 50, and so therefore my profit of 1,050 is going to equal 950. So what does that mean? We had a profit of $950 when we have a revenue of $1,000 and a cost of 50. All right, it's easy. All right, now, independent and dependent variables. Just like before, independent and dependent, in old functions, like if I gave you something like y equals 3x squared plus 2x, and I said, hey, which is your independent variable? Well, you would look at this function and say, well, I'm substituting in for x, so my independent is x, and then I get out y's, right? These are what's coming out of my function, so those are what are dependent, right? They're what depends. So x and y, there we go. So my independent is x, my dependent is y. Well, what is that going to look like when we go to multivariable functions? Well, it's the same thing. Just you're looking into your function and saying, all right, what are all the variables I'm substituting in for? Well, I have independent variables that are x and y. So I have two independent variables. That's all right. That's all right. And now for my dependent variables, which ones are dependent? Well, that's weird. Let's go back to the other problem for a second. Now, I put a y here, but in the past, if we were using function notation, maybe we would have written it as f of x, right? And you still would have told me my dependent variable is y, wouldn't you? So where did that y come from? It's just alphabetical order. What comes after x? Well, y does. So we have x, then we have y. So what variable is going to come out? We can't put y because we already used y. So what comes next? Z, of course, like alphabetical order. Now, you might be saying, what comes after Z? Well, good news. We live in a three-dimensional world. We only have three variables in our 3D world. But if you needed something else, you just pick another letter. It's W or Q or whatever, T, whatever you want. If you had another function, maybe that looked like h of x, y, z, where we're going to have something like x, y, z plus 3x squared, something like that. Well, my independent variables here would be x, y, and z. So therefore, my dependent variable, what am I going to call it? Oh, w. Great. Okay. So it's just for you. And most of the time you're going to have meaning. You're not going to have all these silly x's and y's. You're going to have profits and revenues and costs, and you're going to have volume. So here's a perfect example. What are the independent variables of our volume equation, the way it's written? Well, our independent variables are L, W, and H. You tell me a length, you tell me a width, you tell me a height. Boom, there we go. Those are my independents. And I can calculate for you the output, the dependent variable, volume. But again, it's not so difficult, right? When you just kind of start putting in context. Okay, now, graphing by hand. First thing we have to understand about graphing in 3D. Normally in 2D, we would graph like this and say, hey, here's our x-axis, here's our y-axis. 3D is going to get a little more fun. In 3D, it's going to look something like this, where we have three axes. The one that's coming, this axis here, the x-axis, you can imagine is coming in and out of your TV screen or your computer monitor or whatever you're looking at, right? And then, so the positive values are coming out at you, and so then, therefore, these would be like the negative x's going back this way. Then this axis here is the y-axis. So, and this is going left and right. So again, positives to the right, and negatives to the left, which leaves us with z. So z is going up and down. And if you need to help kind of picture this, just picture a corner in your room. Pick any corner in your room, and you can see think of the wall that's coming at you. That's the xy. That's the x-axis. The wall that's running in front of you. That's the y-axis. And then the z is going from the floor to the ceiling. And there you go. Now, let's graph these things by hand. Not going to happen. Ha ha ha. Yeah, we're not doing that in this class. Okay, we're not going to graph these things by hand. But what I want you to do, just very quickly, is just stick with me for a second and say, all right, x squared, right? What does that look like? If I just gave you the graph of y equals x squared, what does that look like? Well, in 2D, that is a parabola opening up. So in 3D, it's going to look very, very similar. It's just going to be a parabola in the x direction, and then we're going to have a parabola in the y direction. And so if you kind of put together a parabola in the x and a parabola in the y, if you kind of imagine what that might look like, it's going to kind of look a little circular. It's going to look a little, but it's not circles, they're parabolas. But actually, well, they are circles, but that's beside the point. If you sliced from the top, they would be circles, but the sides would all look like parabolas. But it would look like a little bowl, right? All right. Now, what we're going to do is we're not going to do these things by hand. But I just want to give you a little brief idea of that's, kind of what it would look like. We're going to use these using technology. Now, these use this actually isn't totally true. It uses JavaScript. So you just need any web browser with JavaScript enabled. So what I'm going to do is start another video where we're going to go over how to use this. So just go to this website, and we're going to graph these two graphs from up above in this plotter.